All right, ladies and gentlemen, in this blast from the past lesson, I'm going to be going over order of operation questions. Looking at our first question, it's got -2 plus 5 plus 2 squared. I'm going to go over this one with you, and then the other problems you're going to be working on your own. And some questions will be asked as we go through the problems. So anytime we're dealing with order of operations, the first thing I want to look at is PEMDAS. PEMDAS stands for parentheses, exponents, multiplication or division, whichever comes first in the problem going from left to right, addition, subtraction, again, whatever comes first in our problem going from left to right. So let's go ahead and take a look at this problem and solve. Looking here, we've got our -2 plus 5 plus 2 squared. Do I have any parentheses? No, I don't have any parentheses. So now I'm ready to move on to exponents. Do I have any exponents? Yes, 2 squared is an exponent. 2 squared is the same as saying 2 times 2. 2 times 2 is 4. I'm going to bring everything else down exactly how I see it. And let's see what we're left with. Do we have any more exponents? No. Do we have any multiplication or division? No. Do we have any addition or subtraction? Yes, we actually only happen to have addition. So we're going to go ahead and take care of that going from left to right. So I'm going to take care of this piece first. -2 plus 5. So whenever we're dealing with adding integers, we need to think if you had 2 negative tiles and 5 positive tiles, which one do you have more tiles of? We've got more positive tiles. How many more positive tiles do we have than negative tiles? 3. So our answer is a positive 3. Now we just need to bring down the rest of the problem. And again, we still have addition. So 3 plus 4 is going to give us 7. So 7 is our answer for this problem. For our next problem, again, I wrote PEMDAS in the upper left-hand corner to kind of use as a guide. We've got -6 times, that dot means multiplication, 3, all divided over 9, plus a -1. So anytime we see these types of problems, what we want to do is we kind of want to tackle this first. I know it kind of goes a little bit against the order of things, but we want to make sure that we basically get all the numbers on one line. So this kind of looks like it's 2 lines here. So let's go ahead and get rid of that. So to solve this, I'm going to take care of that -6 times 3. Anytime you're multiplying or dividing by negatives, if the signs are different, our answer is negative. -6 times 3 is going to give us -18. I'm going to write that all over 9. I'm going to bring down my plus and my -1. Now, we still don't have it all on one line, so we definitely want to take care of this piece next. This is a division problem. -18 divided by a +9. Because the signs are different, our answer is going to be negative. And 9 can go into 18 2 times. Now we're going to bring down the rest of our problem, which is plus -1. So now we have adding of integers. If you had 2 negative tiles and another negative tile, you end up with 3 negative tiles. So our answer would be -3 for this problem. For this problem, we have -8 divided by 2 plus, in parentheses, -7 minus 1. So looking at my PEMDAS, the first thing I want to see is if I have any parentheses, and I actually do right here. -7 minus 1. Now, whenever we're subtracting integers, it's very important that we turn it into an addition problem. So -7 minus 1, we basically want to switch. So we want to keep the -7. We're going to change that minus into an addition, and we're going to change this +1 into a -1. So now we have an addition problem that we can work with. If you have 7 negative tiles and you add another negative tile, you now have a total of 8 negative tiles. So that would be -8. I'm now going to bring everything else down. And I'm going to kind of put this in parentheses to protect that number. Okay, and now we're checking for any more parentheses. Yes, there's parentheses here, but that's just protecting the number. There's no operation going on inside here. Now I'm looking for exponents. I don't see any exponents. I'm looking for multiplication or division, and in this case I do see some division here. So we've got negative 8 divided by 2. Remember, when you're multiplying or dividing by negatives, if they're opposite signs, then our answer is negative. 2 goes into negative 8, negative 4 times. Going to bring down the plus and the negative 8. Now all we need to do is add our negative 4 plus our negative 8. That's the last operation that we have. If we had 4 negative tiles and 8 more negative tiles, we now have a total of 12 negative tiles. So our answer is negative 12. For this problem, we have the absolute value of 4, that's what those bars mean, plus negative 9 minus 10, all divided over 5. So with this problem, we want to get all the numbers down on one line. So let's take care of everything that's up top here, and then we can divide by 5 at the very end. So I'm going to rewrite this. First of all, the absolute value of 4 is a positive 4. Because 4 is 4 spaces away from 0. I'm going to go ahead and bring everything else down. Now, looking at our PEMDAS, I don't have any parentheses apart from this, which is just protecting the number. We don't have any exponents, we don't have any multiplication, and we don't have any division. So we're left with addition and subtraction. So we do whatever comes first, going from left to right in the problem. So I'm going to go ahead and take care of that 4 plus negative 9. If we had 4 positive tiles and 9 negative tiles, we have more negative tiles than we do by positive. So we would want to put a negative. How many more negative tiles do we have than positive? 5. So our answer would be negative 5 for this. I'm now going to go ahead and bring down that minus 10. So now we're left with this subtraction problem, negative 5 minus 10. Whenever we're dealing with subtraction of integers, we always want to make sure we keep it switch so that we can solve it. So I'm going to keep this negative 5 as negative 5. I'm going to change the minus to a plus, and this positive 10 is now going to be a negative 10. So now all we have to ask ourselves is, if we had 5 negative tiles and we added 10 more negative tiles, how many negative tiles would we have altogether? And that would be 15. So we have negative 15. Now, we are not done with the problem yet. We've only taken care of this top section, basically your numerator. We need to take care of this denominator piece. So I'm going to write this negative 15 right here, since all of this equals that. And then I'm going to put my division of 5. So now to solve this problem, all we have to do is see how many times can 5 go into negative 15. Remember, when you're multiplying or dividing by negatives, if the signs are opposite, then your answer is going to be negative. So let's go ahead and automatically put that negative symbol down. Now we just need to think, how many times can 5 go into 15? And it can go in 3 times. So our final answer for this problem is negative 3. For our last problem, we've got 3 squared minus 2 to the 3rd power. So following order of operations, I don't have any parentheses, but I do have exponents. So I'm going to take care of this first exponent. 3 squared is not the same as saying 3 times 2. This 2 is saying, hey 3, you need to multiply by yourself twice. So that's like saying 3 times 3. And 3 times 3 is 9. We also have this exponent right here. 2 to the 3rd power is not saying 2 times 3. This 3 is saying, hey 2, you need to multiply by yourself 3 times. So that's the same as saying 2 times 2 times 2. Well, 2 times 2 is 4, and 4 times 2 is 8. Now I'm going to bring down my subtraction problem, and now all we have left is 9 minus 8, and 9 minus 8 is 1. So hopefully this video has kind of helped give you a reminder about how to solve order of operations. These types of problems are not going away, and you will see them on your SOL test.